Statistics questions 2. It has a lot of graphs in this one. I actually have all of the graphs already done here, so you could kind of see all of the graphs there. So we have about 5 questions, and I already drew the graphs, so we don't have to spend time with me drawing graphs, right? The marks obtained by 10 students in a test, all right, scored out of 60 are shown below. And I'm seeing these are 10 students here, right? For the data above, determine the range. So what I'll need to do is I'll need to sort it. So how about let's put, marks out of 60 for 10 students. So this is the marks here out of 60. And what's the lowest?
26.
26, thank you. 26 is the lowest, and then what? 29, and then 31,
31.
35, 37, 38 3 times, 42, and 45. So the range here, and this is a simple range question in this particular case, right? So in a simple range question, you can see we don't have to use boundaries here. We just have to use your normal 45 minus 26. So 40, where's my calculator? Oh. Start our math class and I even can't find my calculator. 45 minus 26 is 19. So it have a 19 mark span that these are getting. The median here, well, out of 10, we already put them in order here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The median will be in the middle, which is these two. So the median will be 37 plus 38 divided by 2.
So I get 37.5.
Thank you very much. The interquartile range. So look at that, it's a whole range question we have here. The interquartile range means we had to find Q1. If this is Q2, notice Q2 is here. And that splits this up into 2 odd numbers. So it's easy for me to find Q1. Q1 will just be here. And then the middle of this will be here. So the interquartile range will be Q3 minus Q1. Which is 38 minus 31. I can't believe I'm going to my calculator to do this. Thank you very much. Yes. Okay. Right. And I think we have here the probability that a student chosen at random scores less than half the total marks in the test. So the total marks in the test is 60. Right? The probability, so we want less than half the total. If the total is 60, half the total is 30. So they didn't say less than or equal to it, they say less than half. So I want less than 30. How many students got less than 30 here? 2 students, yes. So the probability of choosing a student that got less than 30 will be what we want. That is students that less than 30. 2 students over the total, which is 10 students. The probability will be what? 1 in 5. We have one here that does require a graph. And let me just check this and see what they're asking me for. Right, and that is the whole question over here. Actually, I think this is part B of this question, Yeah, I think this is part B of this question. Maybe. We'll see, right? The frequency, they use the word here. The frequency distribution below shows the masses in kilograms of 50 adults. 50 is the total here. Prior to the start of a fitness program. And I could see here that we're dealing with grouped data. I could see here that they were kind enough to give us the midpoint, and they were kind enough to give us the frequency. And I'm guessing if I add all of this up, I will get 50. All I have to do here in this question was using a scale of 2 centimeters to represent 5 units and 1 centimeter to represent 1 unit, draw a frequency polygon. That's all you have to do. So this is a good reminder that when you are dealing with grouped data, you have to find the midpoint if you want to draw a frequency polygon. Yeah, so you have to find the midpoint. And so you could see here, this is what the frequency polygon does look like. Where I have what they say, using a scale of 2 centimeters to represent 5 units on the x-axis. Right? Remember, frequency always goes on the y-axis. So midpoint is on the x-axis. And I'm using 2 centimeters to represent 5 units. So that means that I'll start with from 0, I'll go 2 centimeters, that is 60. And I'll go 2 centimeters, 65, 2 centimeters, 70, 75, 80, 85, 90. And well, I cover the full range there from 60 to 90. All right, that covers the range of the midpoint here. The midpoints of them. And then I plot, actually no, not plot, the y-axis now is 1 centimeter to represent 1 unit on the y-axis. This is not a cumulative frequency, yeah? This is a normal frequency polygon. You notice how it does look like a normal distribution curve. Yeah? It is, your frequency polygon usually, not all the time, but usually ends up looking like your normal curve. You could even see it here. You could see the curve in the table, because, you have your bigger numbers here, and then it tapers off into smaller numbers. So you could see that this probably has some positive skew in it. Right? Just because all of the bigger numbers are here, and then coming off here, we have some very smaller numbers. So you could literally look at this and imagine what your curve going to look like, where the bigger numbers are and the smaller numbers are. So because it's just normal frequency, the highest number I had to reach is 15. So I will go 1 centimeter to 1 unit on the y-axis. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 16 is where I went. And then of course you just plot 62 against 8. Well, you could see here, if I go into this, if this is 60, this will be 61, this will be 62, 63, 64, and 65. So 60, 61, this is 62 here, and 62 going up, plotting against 8. And that is pretty much it. And then we'll have 67 against 11. So you can see that 65, 66, this is 67 here. 67 is plotting up against 11. And of course, you could plot out the rest of them. So you can see 72 is plotting against the 15. 70, 71, 72 is about there. And that about here, so plotting against 15. That is your point. And then when you go to the other points, remember, right? Remember, guys, this was your first point. This was the last point. So the curve actually goes from here. You could see the skew now. When you just look at it like that, you could kind of see the skew. Yeah. But even though this is your first point and this is your last point, you should close the polygon down to 0. 0 on this side, and down to 0 on this side. So remember to close your polygon. So this one here was just a simple draw a frequency distribution polygon from a table, and they were kind enough to give you the midpoint. We do have another one here. Let's take a look at this question before we look at the graph, right? The heights of a sample of seedlings were measured to the nearest centimeter. All right, I see in height in centimeter. I see in they have grouped data. I see in here that they had to find the midpoint. And they leave it blank for we to finish. And I see here that they give us frequency and then arranged in class intervals as shown in the table below. How many seedlings were in the sample? So these are the number of seedlings. That is your frequency. So I have to add up all of that in order to get how many seedlings were in the sample. Anybody want to help me out here? Nice. For the class interval written 8 to 12 in the above 8 to 12, that's this one here. Okay. Write down the lower class limit. So 8 to 12, what's the lower limit, guys?
8.
8. Very good. The upper class boundary, 8 to 12, what's the upper boundary?
12. 0.5.
12.5.
12.5. You remember?
Wait, so how is 12.5?
All right, so the
Wait, how
yeah.
upper limit is 12.5 and how the lower limit is just 8?
Well, no, you're using the wrong words. This is not the upper limit. This is the upper boundary they asked for.
I mean the upper boundary.
Well, boundary and limit is two different things. Remember
Oh.
that, right?
Oh, I didn't see that there. I didn't see that.
So remember that the limit is the actual number, 8 and 12,
Oh, okay.
right?
Mm-hmm.
Remember the boundary. The lower boundary is 0.5 below this, the lower limit. So this is your lower boundary here, which will be 7.5. Right?
Mm-hmm.
And the upper boundary is 0.5 above the upper limit. So the upper boundary will be 12.5.
Oh, okay, so I understand.
Right? So remember the difference between boundaries and limits. That's okay, Chevelle. That is why we do these questions. Yeah? You make these mistakes now, make the mistakes now. Don't save them for exams. Make them now, right? The class width. What's the class width, guys? Huh?
Right?
How do I calculate that?
50, 12.5 minus 7.5.
Right. So till we get class width, we have to use the boundaries. Right? So that is the lower boundary plus the upper boundary divided by 2. Is that it? No, that's the midpoint. Where's the width? The upper boundary minus the lower boundary, right? Yeah, so the upper boundary is 12.5 minus the lower boundary, which is 7.5. So that's the next thing, Chevelle. It have when you're calculating class width, and you're calculating class midpoint, you don't use the limits, you use the boundaries.
Oh, so it's when you're finding for the limit is not the boundaries you're finding for, it's the limit.
You mix up your words there. When you are finding class width and class midpoint, those are the two things you had to find, the width and the midpoint. Right? Right?
Yeah.
You do not use your limits, you use your boundaries. In fact, any calculation that had to do with the class, you never use the limit for any calculation. You always use your boundary.
Okay.
Right? So 12.5 minus 7.5 is 5.
Okay.
So the class width is 5.
Okay.
Now they say copy and complete the table by inserting the midpoints of each, the missing values for the class interval after. Oh, so it have another class interval after this. All right. So it have another class interval after this. The first thing we had to do is the midpoints, right? So the midpoint, and you'll see here, if I come here and I use my boundaries, right? The midpoint. I use the boundaries, so that's 2.5 plus 7.5 divided by 2. I will get 5. I just check in to see if I get 5. So now this one here will be the boundary is 17.5 plus the upper boundary is 22.5 divided by 2. Ali, want to help me? What's the midpoint for that?
20, 25, 30, 35.
20, 25, 30, 35. And I guess the midpoint for this one will be 40, right? Because they're telling me here that it have another class. The missing values for the class interval after the interval 33 to 37. So this will be what? 34.
I had 38 to 42.
Oh, 38, right. It will be 37. It'll be 38. Yes, it will be.
See, I have my feeling dyslexic from it.
Nah, sometimes I just get dyslexia going. Now 38 to 42, let me see, 3, 4, 5, 6, 7, right? So 38, 39, 40, 41, 42. Yes, 38 to 42, yes. The midpoint here will be 40, yes. But I don't know where's the frequency, because remember, we added up the frequency. And
I think it was only supposed to do the height column.
Right, I was only supposed to do the height column. Right, yeah, and the missing values for the class interval after the interval. Yeah, but I don't know. Because I mean, it have no way I could have followed that anyway. Because I don't know, they didn't tell me what the total is, and my total is 85 based on adding up all of this. The total is 85, right? So I guess I'll have to live with that. And using a scale of blah, 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 draw a frequency polygon to represent the data as shown in your table, right? So you can see here that a frequency polygon, and look, it looks like a bell curve again. Yeah, and as I say, you could even see the bell when you look at the frequency itself. When you look at the frequency itself over here, you could see that we're starting from 0 and we have low numbers, and then the numbers get real high and we ending up real high. So it definitely, you could see the skew here. You could see the skew in this, right? So there's definitely some sort of skew. So we have to use 2 centimeters to represent 5 centimeters on the x-axis, the horizontal axis. So this is the horizontal axis there, and my lowest is 5 and my highest is 35 or maybe 40, I don't know. So yes, I'll go from 5, 10, 15. Notice I'm using 2 centimeters here to represent 5 centimeters of height, 2 centimeters from 5 up to 40, right? So I have my 40 over here, and of course this 5 does have to link back with the 0. By the way, I didn't close it, so now I'll close it on this side, and we can see it's already been closed on this side, right? So on this side it definitely has to close, right? And then, so the midpoints are used for there, and the frequency, well, the highest frequency I have to deal with is 22, they tell me here to use 2 centimeters to represent 5 seedlings on the vertical axis. So on the vertical axis, 2 centimeters here representing 5, 10, 15, 20. And then of course you just plot your points, right? So you go see here that, oh, actually it already is closed, right? Because that 5 there has a frequency of 0. So it actually does reach to the 0. So it is closed there. My bad. Yeah, so that 5 is 0 there. And the 10 have a frequency of about 3, which is about there. Yeah. So 1, 2, 3. Yeah, I guess this one not very accurate going up. So I had to kind of average it again. Nice, you can see we have a cumulative frequency curve on this side. Let me see what the question asking us first. Oh gosh, why are you not zooming? Okay. The table below gives the distribution of heights of 400 female applicants for the police service. So I see in heights here, and as we gain plenty grouped data questions, so we gain some good exercise, right? This here is the normal frequency, and this here is the cumulative frequency. They were kind enough to fill these things out for us, right? Out of 400, right? Using a horizontal scale of 2 centimeters to represent 5 centimeters on the vertical, right? Now, I don't know what they're asking us, or they're asking us for a cumulative frequency curve. So that means cumulative frequency gonna go on the vertical, and that means that this is gonna go on the horizontal. Now that we're talking about cumulative frequency, Deja, now we're dealing with less than. Yeah, now, because it's cumulative frequency, right? So now I could say that, well, you know what? Less than or equal to 155 is 10 people, right? And that 10 plus the 55 is 65. So less than or equal to 160, that is 65 people. That is, these people here are less than 160, right? And this will be less than 165, less than 170, less than 175, less than 180, less than 185. You can see here in this case, I have to use 2 centimeters to represent a 5 centimeter and a vertical scale. All right, so on the horizontal scale, 2 centimeters representing 5 centimeters. So I started with the 155 here. I actually started 0 by 0 with 150, 155, 160. So 2 centimeters representing 5 centimeters of height, right? So 2 units representing 5 centimeters of height. Yeah, so 155, 160, 165. That's how I have it going up until my highest was 185, right? And then they say, and a vertical scale of 2 centimeters to represent 50 applicants. So you can see I've gone from 0 to 50, from 50 to 100, and so forth. 2 centimeters representing 50 applicants, up to 400. Yeah, and now I just plot my points, right? So you can see here that 155 is plotting a cumulative frequency of 10, which is about there. Yeah, 160 is plotting a cumulative frequency of 65, which is about here, right? 165 is going up to 170, which is about here. 170 is going up to 280, which is about here. And you notice my graph a little bit wonky, and this graph paper is not very accurate, because it is a bit wonky because of the wonkiness. 175 going up to about 360, which is there, right? 180 goes up to 390, which is there, and then 185 goes up to the 400. And this is your classic S-curve for a cumulative frequency. All cumulative frequency curves look like this, all. So if yours looks different from this, you do something wrong. All right? Once you see a cumulative frequency curve, you need to expect this shape to come out of it. The accuracy of these graphs are so important, and especially in this case where they ask you to draw the graph first. That means they're going to ask you questions based on the graph. So let's see, and whenever they do cumulative frequency, a curve, they have lots of questions they can ask you based on the graph that you have to go to the graph to get, right? So use your graph to estimate, and you notice the word estimate here because they know that different students will get different answers. But all the answers will be around a certain range, yeah? The number of applicants whose heights are less than 170. So the number of applicants whose heights are less than 170. So I'm gonna come here to 170, and from this 170, this is less than 170, right? So I'm gonna go up here, and it's important that when you actually doing these questions, please come and show your lines, show your lines, show that you're putting a dotted line here from the 170. Show these dotted lines so that they will know that this person actually went to the graph. So 170 lines up with 170 did line up with what? 170 here lines up with 280. So that's about 280 people. So 280 people are the number of applicants whose heights are less than 170. That's 280 people are 170 or less. All of these 280 people here, from 0 to 280, they are within this zone of the graph, which is less than 170. Any questions on that? The median height of the applicants. I mean, whenever you see a cumulative frequency curve, you don't know they're gonna ask you for median, right? 400 is the total, so a half of 400 will be 200. This is where your Q2 is, and I will go across like this and about here, so I'm gonna try to come down very carefully. And as I say, this is an estimate, so your answer might be slightly different based on how you draw your curve, right? That is okay if your answer ends up slightly different. About here, so if this is 165 and that is 170, the middle of 165, 166, 67, 68, 69, 66, 67, 68, 69. All right, so I would say about 166. If you had 165, no, 165 you would not get correct, right? But if you had 167 or 166.5, or 167 or whatever you got here, they would have given you 166, 167, 168. They would have given those answers correct. So I get in here based on my inaccurate graph, the median Q2 is, the median height is about 166.5. Right, almost 167, but my graph is a little inaccurate. If you had 167, that is fine. The height that 25% of applicants are less than. This is a Q1 question. Because you know Q1 question. Q1 is 25% of your total. So the first of all is 400. So it's 25% of 400 people. That is 100. So my Q1 is 100. This is 25% of people. So 100 or less will be less than this height here, which is about 161. Let me call it 162. All right, so 162 here. This height here lines up with my 100 people. So that means that 25% of applicants are less than 162 centimeters. Any questions on that one? So you're seeing here the kind of questions that they could ask you based on your cumulative frequency curve. They could ask you all kind of things, especially this last one here. Now you see here, credit will be given for drawing the appropriate lines on your graph to show how the estimates were obtained. So this line here showing the 170. This line here showing how I measure Q2. This line here showing the 25%, which is Q1. These you will get credit for that. Yeah. And now they will, if they're giving you a cumulative frequency graph, two questions that they will ask you. The first one is for Q2, and the second one is a probability question. They will ask you these things. The probability that an applicant selected at random has a height that is no more than 162. Not more, be careful with the words. Not more than 162. So your height coming up, and then you hit 162. You don't want more than that. So that means that you want the probability that somebody is less than or equal to 162. Right? And I'm gonna come, well, look at that. 162 just happens to be my Q1. And I can see that that lines up with 100 people. So 100 people are less than 162. 100 people are less than or equal to 162. Therefore, the probability would be the 100 people, because these are what I want.
Over the 162 because I
No, over the total, which is 400. The probability that an applicant selected at random has a height that is no more than 162.
Mm-hmm.
So no more than 162 means 162 or less. So
so that's why you get the 100.
Right, yeah, well, I come here to 162 and I see that 162 lines up with 100 people.
Mm-hmm.
Right, so 100 people, right, are 162 or less, because this going from 0 to 100, so this section of the graph is 162 or less. And
oh yes,
right,
yes.
so this probability of 160 less than 162 is 100 people over the total amount of people, which is 400 people. And so the probability is 1 in 4. Let me see what's going on with this question here. A class of 32 students. I guess I had to read through that. I didn't cross off them thing. That's how I get the paper. You know all of these papers, this be bootleg thing, right? A class of 32 students participated in running a 400-meter race. All right. I'm guessing this 400 might have nothing to do with nothing. In preparation for their sports day. The time in seconds taken by each student is recorded below. It's 32 students, right? So 1, 2, 3, 4 by 8. 4 8s are 32, right? Complete the frequency distribution table to represent this data. All right. So I see here those people who got between 50 and 54. So I'm looking for between 50 and 54. That is 51. That is 54. That is 54. Anybody else between 50 and 54? No, we get 3 people. All right. Between 55 and 59. So 55 here, 1. 56. 58. So that is 3. 1, 2, 3. 59. Yeah. Anything else? No. So we get 4 a day. All right. Between 60 and 64. 63. That is 1. 62. 62.
6.
1, 2, 3, 4, 5, 6. All right, 6. All right, now it's time to help me with the others. 65 to 69 is how much? 65. Asina, 65 here. 1.
68.
To
And then you
69.
did 71 and next to the 73 in the last. Yeah.
68. That's 2.
I get 3. That's alright.
65 on top, sir.
65 on top. Yeah, 65. That's 3, right?
Yeah.
Thank you. Very good. 70 to 74. So that is 1, 2,
2,
3,
3,
4,
4,
5, 6, 7.
7.
I'll get 7 for that one.
I think so. It looks like it.
I get 7.
Yeah.
All right. Okay. Let me go back to red here. 75 to 79. 1, 2, 3, 4. I'll get 4 for this one.
Yes, I get 4.
And then the last one here will be 1, 2, 3, 4, 5. 5?
5.
Yeah,
Right.
5.
Now let's see if we got it correct because it's 32 students in all. So if I add up all this, I'm supposed to get 32, right? So 3 plus 4 plus 6 plus 3 plus 7 plus 4 plus 5 is 32. All right. So once we get 32, we should be confident that we did that okay, right? So you could see that we got raw data and we had to analyze the raw data to put it in a frequency distribution as a grouped frequency distribution. Using the raw scores, determine the range for the data. Well, the raw scores, I mean the range, well, I would have just used this 49.5 and this 84.5 to calculate the range. But they said using the raw scores, right? So using the raw scores, what is the lowest score? 51, and
Yeah.
do I have a 50?
No.
Right. So with the raw scores, that'll be the lowest is 51, and a minus and was the highest.
The highest is 83.
83.
83,
Yeah, 83.
right? So 83 minus 51 is 32. 83 minus 51, yeah. Oh crap, the thing gone on strips. I hate when it does that. So So 83 minus 51. So we have a range of 32 seconds here. So that means the slowest person to the fastest person is 32 seconds apart. Right? Using a scale of 2 centimeters to represent 5 seconds, I'm drawing a frequency polygon. Right? And the
I didn't understand this one at all because I had notes after this.
Alright, yeah. Well, a frequency polygon for grouped data means we have to find the midpoint, right? And I'm not even sure if I did find the midpoints. So we do have to find the midpoint because what are we plotting? And I mean, if we looked right here, we could see, frequency midpoint is how we get a frequency polygon. So we do have to find it. So you see, this is an example of a question where they didn't tell you about your midpoint. So you had to find the midpoint for each one of these things, right? Because we can't plot frequency again. So let's find the midpoints now, right? So let me call the midpoint X, right? And where's the midpoint for this one? That'll be 49.5 plus 54.5 divided by 2, 52. Right? And so 50, 51, 52. I can say 55, 56, 57 here. Right? 60, 61, 62, 67. 72, 77, 82. Yeah. Any questions on how I found the midpoints? Right. And so 2 centimeters to represent 5 seconds. Right. My lowest amount of seconds is 50. So I started with 50 here. And I gone 2 centimeters. So 55. 60, 65, 70, 75, 80, and of course it looked like I ran out of graph paper, so 85 and then 90. Yeah. So let me plot this thing. I'm plotting 3 against 52. So 52 plotting against a frequency of 3. By the way, the frequency here, 7 is my highest frequency. And they say to use 1 centimeter to represent 1 student on the vertical axis. So 1, 2, 3, 4, 5, 6, 7, and I have 0 here. Right? Now, let's see. 52 plotting against 3. So I could see here that this is about 52. And then that is the 3 that I plot there. Right, so this is my 52 against 3, right? 57 plotting against 4. So 55, 56, that is my 57 around there. And that plotting against 4. Right, so I did use the midpoints. 62 plotting against 6. So 60, 61, 62 there. Plotting against 6. So on and so forth. You notice here in the data, Deja, that it does have a huge dip in the middle there, right? So nothing you can do about that. If that is what your data says, then that is what the data says, right? 60.
Chevelle.
Was it Chevelle or Deja that asked me about the dip?
I think it was Chevelle.
It was Chevelle.
It was me.
Okay,
It was.
yes.
I was saying I was fluctuating.
Yeah, that's fine. 67, 3, right? 72 is about here, and that's 72 plotting against 7, right?
Yeah.
50. Deja Chevalier, right?
Yeah, I follow man, yeah.
77 is about here, and the 77 plotting against 4, right? 82 is about here, and the 82 plotting against 5, which is there.
Yeah.
Right? And you can see that this is my first point. This is the last point. Right? Notice that from the first point here, if this is 50, you know, I could have go down to 0 right there at 50 actually. You know, because from this 52, I could have just closed the polygon at 50, go down to 0, right?
Yeah.
Or actually, no, I think that they generally like you to go, because if this is 2 and you're 2 centimeters away from here, then you should you should close it to 0. So you should close it to the next 2 centimeters that there, right?
Okay.
And then
So it could be a full graph.
right, and on this side, you notice how the last is 85, the next 2 centimeters is 90, so I'm closing it to the 90.
Okay.
Right, I'm closing it to there. Right?
Okay, makes sense.
Now this is with the note. Note, an empty interval must be shown at each end of the distribution and the polygon closed. That is what we did. This is the empty interval, and this is us closing the polygon. And Shiva.
Yeah.
It's Deja who asked this question, right?
Yes.
Right. Right. So an empty interval must be shown at the end of the distribution. So I have at this end, I have an empty interval, and at this end, I have an empty interval. And this is what I was talking about here. And from this empty interval here is the polygon. We closing the polygon. From here, we closing it to the empty interval. To qualify for the finals, a student must complete the race in less than 60 seconds. What is the probability that the student from this class will qualify for the finals, right? So the thing is that the frequency polygon doesn't give us this information like how a cumulative frequency curve will give us the information, right? A cumulative frequency curve gives us this. But no, a frequency polygon, a simple one like this, does not give us this, right? So what are they asking for? We'll go to the table, right? And they're saying that as to qualify for the finals, a student must complete the race in less than 60 seconds. So I will go look 60 seconds here. Who are the people that completing it in less than 60 seconds? Notice they say less than, so you're not including the 60. So these are the guys who doing it in less than 60 seconds. Is 7 students doing it in less than 60 seconds. So what is the probability that a student from this class will qualify for the finals? The probability of choosing somebody less than 60 seconds is what they're asking for. That'll be 7 out of the total, which is how much? 32? 0.22. You can see we have a cumulative frequency one here. Last one for the night. I will say we are over early, yes, but I guess these questions take us the full 2. The table below shows the speeds to the nearest kilometers per hour of 90 vehicles. 90 is the total that passed a checkpoint. Speed, frequency, cumulative frequency. All right. For the class interval 20 to 39, as written above, complete the following. Where's the upper limit?
20.
20 to 39. What is the upper limit? 39 is my upper limit. The class width, and of course the class width, I will use boundaries. So it could be 19.5 plus 39.5 divided by 2. 0.5 below and
No,
0.5 above. No?
No. That's a midpoint.
Oh, sorry. With class width. Crap, yes. So class width, thank you, will be 39.5 minus 19.5. The upper boundary minus the lower boundary. Yeah. So, yeah, my brain air want a brain today either. 39.5 minus 19.5. Thanks so much for the help, guys. 20. 16 vehicles passed a checkpoint at no more than 16 vehicles passed the checkpoint at no more than 39 kilometers per hour. And I'll really have to go and do some research to see if it's 39 or 39.5, right? But according to this cumulative frequency table, right? Because remember, in the cumulative frequency table, 16 is the people who are less than or equal to 39. And?
Yes, sir.
Right, so that is why I didn't use 39.5. You understand?
Yes, sir.
Right.
No, because 39.5 will be too much of the kilometers.
The upper limit here is 39. Yeah?
Yeah.
So that means that 16 people were doing 39 or less.
Oh.
Because remember, it's the 11 people that were doing between 20 and 39, and 5 people were doing less. And
Yeah.
so 39 or less is the 11 plus the 5, which is the 16, right?
Oh, okay. Okay. So die hard again the 16. 11 plus 5. Okay.
And that's how we get the rest of the cumulative frequency.
You basically just adding the one on top to the one on the bottom.
Because less than 59,
26 plus 37.
26 plus, well, I don't know where you get 37, 26 plus 16, remember, this is 16, and? Yeah, this is
Wait.
16 plus the 26, and? Less than 19. Right? The people who is doing 19 kilometers or less is 5 people, and?
Yes.
Right. The people who doing 39 kilometers or less, that is this 11 plus this 5, and?
Yes.
So that is 16, and?
Yes.
The people who doing 59 or less will be the 26 plus the 16, and?
Yeah.
So the 16 plus the 26 will give you all of the people that doing less than 59, yeah?
Oh, I understand now. Because that's your calculated for how
So
much
that
people
is
do less than what it
42,
is.
yeah, 42, right?
Oh yeah, okay.
All right, so you're including all of the people that came before, right? So
Included,
all of the people that doing less than 79 would be this 37 plus all of these people, and?
Yeah.
Right, which is the 37 plus the 42, and?
37 plus 42, yeah.
Which is 79, right?
79.
You understand now?
Yeah.
And so to finish the table, the 79 plus 9 will be 88 over here. Right, so 88 people doing less than 99, right? And then 88 plus 2 is what giving me
Is
my
90.
90. And those are all of the people, all 90 people are doing less than 119 kilometers, and?
Oh, okay.
Right? So everybody doing less than 119. On the grid, we have to draw a cumulative frequency curve, right? Use 2 centimeters to represent 20 kilometers per hour. So you notice how starting with less than 19, right? So 2 centimeters represent 20 kilometers per hour. I actually started, and I did, so you see this time, Deja, I did what you did in the last question, where I started from 19 and I went 2 centimeters is 20 kilometers an hour. So That gives me 19 to 39 to 59, 20, 20, 20. I was thinking to start at 20, but you know, you have 19, which comes before 20, right? Which I guess you could have just plugged your point right before the 20, simply because you do have an empty interval before, right? So that could have worked too. You could have also start at 10, just to go 10 to 20, and you'll get your 19 in the middle there, right? But wherever you start, once you plot your points, so 19 plotted against 5. By the way, the cumulative frequency will have to go up to 90, right? So they say here that for the y-axis, you're using 2 centimeters to represent 10 vehicles. So from the 0, I have 10, 20, 30, going up to 90, right? And plot it. So 19 plotting with 5, and I could see that there, 19 plotting with 5, even though my curve kind of draw a little bit, you know, you gotta be a little careful how you draw your curve. I see in here 39 plotting with 16, and it actually worked out for me to plot 19, 39, all of that stuff. So 39 plotting with 16. Chevelle, I hope you're following it, right? 59,
Yes, I'm following.
59 plotting with 42, so that is 40, about 42 up here. Right. So now, anybody have any questions on how we drew the graph? I think we had enough exercise in drawing a cumulative frequency graph, right? And of course,
Yes.
if you have cumulative frequency, please expect to look like a S-curve like that, where it tapering off to becoming flat at the top. Yeah, that is pretty much what your cumulative is supposed to look like. Yeah, always. So, once we draw the graph, yes, we draw the graph. On the graph, draw reference lines to estimate the speed at which no more than 50% of the vehicles drove past the checkpoint. Well, you know what they're asking for. They're asking for Q2. Right, because Q2 is 50%, right? So Q2 is 50% of the 90, which is a half of the 90,
45.
which is 45, right? So I will say 45 is about here. And so I'm gonna cut across the 45. And I'm gonna get about there. And I mean, is it passing the 59? It passing the 59?
I don't know what I do wrong, but I had minus 62.
That's fine. Remember, when you draw your curve, you're gonna draw your curve slightly more bend than somebody else, you know. Somebody else gonna draw their curve slightly more straighter than you. And so you will have a little bit of a leeway. If you get 15, I get 59, you get about 61, 62, and that is okay. That is okay, right? That is why they always use the word estimate. They always use that word because they know that it's not going to be exact, right? So I saying it going past the 59 a little bit there, till about there. So I will call it about 60, right? So I'll call it about 60, or it could be actually 62 actually, yeah, because wait, 59, because one of these just represents 4, so 59, 60, 61, 62, 63. Yeah, I'll call it about 61 then, right? So 61, right? So notice the actual question though. On your graph, draw reference lines to estimate the speed at which no more than 50% of the vehicles drove past the checkpoint. So 50% of the vehicles, half of the vehicles, right, drove past the checkpoint at 61 kilometers. No more than 61, eh? Because remember, if we count this to be the 61, then anything below the 61 here is, you know, anything is less than 61. From 0 to the 45, all of these guys here are less than the 61. So no more than 50% of the vehicles. All right. On your graph to estimate the speed at which no more than 50% of the vehicles drove. So 50% of the people, no more than, I get around 61. If you got about 60, 62, that's fine. No problem with that. What is the estimated speed? Oh, so this one here was to draw the reference lines. And this one here is to actually give the estimated speed. So you can see here you get 1 mark for these reference lines. All right. Any questions on this one here?
No, sir.
Now I just want you now.
So
Yes.
91 above. Oh.
Say that again.
What is that negative? One in top.
Oh, you mean this here?
Yeah.
Yeah, that's actually a physics thing. But it's a physics thing that comes from your laws of indices, right? Because remember, speed is distance over time. And that's a physics thing. When we do speed time graphs, we will do this formula, right? But it's a physics thing, and this shows up in so many places, right? Distance is kilometers. Remember, kilometers is to the power of 1. And over time, h is to the power of 1. So if I was to bring this h up, the laws of indices says that that is h to the power of -1. Because remember, when we did the laws of indices, anything to the power of -1 is 1 over to the power of 1, right? You understand, Karen?
So,
Right. So that is just a matter of units. Right? That's just a matter of units, and you could see that they used that over here. You understand? That is where I got it from. So even if you didn't know about it, it is there in the question. You understand, Karen? All right. Any other questions? All right. I just want you guys to look. Huh?
I could get statistics I review in stars.
Sorry, you could get what?
Give statistics I review in stars.
Give statistics a review.
Yes.
Well, that's
like
how
much I rate it.
How much you rate it?
How much I rate this subject.
Oh yeah, how much do you rate it?
Like 3 or 2.
-5.
3 or 2 out of what?
5.
3 or 2 out of 5. Okay, yeah, that's not bad. Yeah, you don't like stats.
I didn't say
I
that.
didn't-
I
I
didn't
really
think
like
that's
it.
that.
Now, we do have a little bit of cheat sheet here. This is the cheat sheet we were talking about for statistics. And I mean, this doesn't cover everything, but it does cover most things. Right? We were seeing here that on this side we have ungrouped data, and on this side we have grouped data. Ungrouped data is just dealing with these discrete data forms. Grouped data is this continuous data forms, and we have to use class intervals for them. Yeah. Now, whether you are dealing, and what statistics is about, all that statistics is about. Because when you was in SCA, you're studying things like mean, median, and mode, right? And how to find average. But now we're dealing with big people thing, because in the real world we have large amounts of data, and when we have large amounts of data, we have to use frequency to analyze that data. So the question becomes, when we're dealing with frequency, large amounts of data, how do we find mean, median, and mode when we're dealing with large amounts of data? The way that we know how to find average in SCA, that can't work here because it's too much data. Yeah. So the whole, what statistics is all about is pretty much how you find mean, median, and mode. For ungrouped data, we have it here. Yeah. Where we have the mean here, look, the median here, and the mode is the highest frequency here. Yeah. And then for grouped data, we have it here, where to find the mean, we use the same formula, but we had to have a fx column. Remember the fx column, right? And remember we had to find midpoint and thing for that. That's to find the mean. Yeah. For the cumulative frequency, yeah, we had to find, for the Q2, we had to have a cumulative frequency curve and do the whole curve thing. And we got a lot of practice with this today. And I have never seen the mode of grouped data in an exam. But that is the one where we had the histogram and you had to do the funny simmy-dimmy with the histogram. I've never seen it in an exam. That doesn't say that it wouldn't come. Right? Then we started to talk about measures of dispersion, and that had to do with your Q2 and your Q1 and your Q3, your interquartile and semi-interquartile range. And of course, at the end of the day, we talked about probability. We did not put all of the probability formulas in this cheat sheet. That is the one thing that's missing from here. Because remember, we had mutually exclusive events, we had independent events, we had conditional probability. Yeah, but you can see that none of the probability questions that we got in these papers here asked us anything about that. No, all of the probability questions were just simple, straightforward probability or finding probability from a cumulative frequency curve.